All right, number one, we're dealing with the chain rule here. So we're asked to find a derivative of this radical expression. So let's go ahead and calculate that. The first derivative would equal, I'm thinking of this to the half power, so I get a half times the quantity 17x minus x to the fifth. My power gets reduced to negative a half. And then I have to multiply it by the derivative of the inside function here, which would be 17 minus 5x to the fourth. Let's go ahead and clean that up just a little bit. 17 minus 5x to the fourth is in the numerator. The 2 is in the denominator, and this radical, this half power, which is negative, goes to the denominator. So that's 17x minus x to the fifth. So there's number one. Number two, we're asked to do the same thing, just find a derivative. So y prime would equal 1/2 times 7 plus sine 10x to the negative 1/2. But we have to multiply by the derivative of this inside function. The derivative of 7 is 0. The derivative of sine is cosine, so cosine 10x, times, I have another inside function here, 10x is inside cosine, so I have to multiply by the derivative of 10x, which is 10. Let's simplify a little bit right here. Half of 10 is 5, so we can take care of that right there, and then go ahead and clean this up. So I've got 5 cosine 10x in the numerator, and in the denominator I just have this radical 7 plus sine 10x, and we're done. That's number two. Number three, we're finding derivative here by implicit differentiation. So let's go ahead and derive. The derivative of 5y squared is 10y, but that y is a function of x, so we got to multiply by its derivative, plus 7x squared, the derivative would be 14x. The derivative of 17 is 0, and the derivative of 0 is still 0. I'm trying to find a derivative here, so I need to isolate this value, this y prime. Let's go ahead and subtract 14x from both sides, so 10y prime equals negative 14x. Divide by the 10y, y prime equals negative 14x over 10y, and let's reduce. Y prime equals negative 7x over 5y, and we're good there for number three. Number four asks us to do a little more work. They want a first derivative and a second derivative this time. So let's go finding that first derivative. The derivative of y squared is 2y times the derivative of y is y prime, minus the derivative of x squared is 2x, and that equals the derivative of 7 is 0. Let's add that 2x to both sides, so 2y, y prime equals 2x. Divide by 2y, y prime equals 2x divided by 2y, and reduce, y prime is just x over y. So I've got my first derivative there, y prime equals x over y. Let's copy that up here, and then go ahead and create some space to work on that second derivative. So that second derivative would take this and take its derivative. So let's take y double prime is equal to, if I follow a second derivative here, I got to do a quotient rule. So I'll square the denominator, I'll keep the denominator, and multiply by the derivative of the numerator, which is 1, minus, keep the numerator and multiply by the derivative of the denominator, which is y prime. Well, y prime is x over y, so let's go ahead and make a substitution there. Y minus x times x over y is x squared over y, and that's all over y squared. This is a compound fraction. I don't want to leave my answer in this form, so let's clear this denominator by multiplying everything by y. So I multiply the whole numerator and the whole denominator by y. That's just multiplying by 1 in a sense, y over y. That gives me y squared minus, this reduces out, x squared over y cubed. So my second derivative is y squared minus x squared over y. I said cubed, but I wrote squared. That's y cubed. That's number four. Number five, we're doing related rates here. We've got water falling on a surface wetting a circular area expanding at a rate of 10 square millimeters per second. And we're asked how fast is the radius expanding when the radius is 152 2 millimeters. So let's see, we're given dA dt, how fast the area is changing. That's 10 square millimeters per second. And we are asked to find dr dt. So they're asking, saying dr dt is what when r is 152. We need some function that relates the area to the radius. The only one I can think of is the area function. I'm sure there are others. So the area function is equal to pi r squared. That's the area of a circle. Derive both sides. dA dt is equal to 2 pi r dr dt. I want to know dr dt, so let's solve for that. Dr dt is the same as dA dt divided by 2 pi r. We have values for everything here on the right, so let's go ahead and substitute and calculate. dA dt is 10, 2 is 2, pi is pi, and r is 152. So if we take this and put it in a calculator, we get 10 divided by 2 pi times 152. That comes out to approximately, dr dt is approximately, to 4 decimal places is what they want, 0.0105, and that is millimeters per second. That is that's a funny looking approximately. That's number 5. Number 6, we've got that ladder slipping down a vertical wall. The ladder's 20 feet long. It's slipping at a constant rate of 3 feet per second down. How fast is the bottom of the ladder moving along the wall when it's 16 feet from the wall? So for these, I like to have a diagram. So here's my wall, here's my floor, and here's my ladder. I know that ladder is 20 feet long. I'm going to call this y, it's a vertical distance. I'm going to call this x, it's a horizontal distance. I'm going to assume that we built the wall perpendicular to the floor. They gave me dy dt in my variables is negative 3 feet per second. Negative because it's going down, it's decreasing. They asked for dx dt when x equals 16. Well, when x is 16, this value down here, when that's 16, a little Pythagoras will tell us that this has to be 12. You can kind of see a 3, 4, 5 triangle hiding in here. So that's when y is 12. So let's go ahead and use a function that relates x and y. The obvious one to me anyway is Pythagoras. So x squared plus y squared would equal 20 squared. Let's derive both sides. 2x x prime plus 2y y prime. Actually, I don't want to use primes here. I want to use the other notation. So I've got 2x dx dt, there we go, plus 2y dy dt, because we're doing this with respect to t. That's why we derive the x and the y in this fashion. 20 squared is, the derivative of that is 0. Derivative of constant 0. I can divide both sides by 2 and knock those guys out. So I've got x dx dt plus y dy dt is equal to 0. I'm trying to find dx dt, so let's make sure we isolate that. So x dx dt would equal the opposite of y dy dt. If I totally isolate dx dt, I'm going to have to divide by x on both sides. So dx dt is equal to the opposite of y dy dt, all divided by x. I have values for everything on the right, so let's go ahead and substitute those and calculate. The opposite of y would be negative 12. dy dt is negative 3, and x is 16. I'll go ahead and calculate, and what we get here is 2.25. So that's 2.25 feet per second is how fast that ladder is moving out away from the wall. 2.25 feet per second. That is number 6. 7, we've got two numbers whose sum is 240. We're trying to find a maximum product for those two numbers. And they help us out a little bit here. They say that our product is xy, and we're told that x plus y is 240. Well, if x plus y is 240, then y equals 240 minus x. If if I substitute that in, then q, not q prime, just q right now, q is equal to x times y, which is 240 minus x, or 240x minus x squared. X times 240, x times x. So therefore, q prime, the first derivative here, is equal to 240 minus 2x. This value only equals 0 when x equals 120. Therefore, x is 120, and y is 240 minus 120. Or y is also 120. How do I know this is a maximum? Well, let's look at the second derivative. Second derivative says that we would get negative 2, which is concave, implies that we are concave down. And concave down says that we have a maximum. So my two numbers are 120 and 120. Done. That is number 7. Number 8 is similar. We're looking for two numbers who have a difference of 2 and have a minimum product this time instead of a maximum product. So let's look at our two numbers. If they have a difference of 2, that means one minus the other has to be 2. It also means that to find a minimum product, we could do the same thing. We could say q equals xy. I'm going to let p equal xy. So p is for product equals x times y. If I solve for y, x minus 2 would be the same as y. So my product would be x times x minus 2, or x squared minus 2x. The derivative of my product would be 2x minus 2. This derivative equals 0 only when x equals 1. So it looks like one of the numbers is going to be 1. If x is 1, then y is negative 1. But let's see for sure that we've got a minimum at that value. So let's look at the second derivative. Second derivative would be 2, which is always positive, which tells me we are concave up, which implies always a minimum at our critical values. So there's my two numbers, 1 and negative 1, are the two numbers that have a difference of 2 and a minimum product. That's number 8. 9, they give us a velocity function, and they just want to know the time that this is a minimum. So we're going to take our velocity function and derive it and look for a minimum value. So I would get a 2t minus 6 out of that. This is equal to 0 when t is equal to 3. Now we just need to see if we're getting a min or a max there. My second derivative would be 2. That's positive, so we're concave up, which implies a minimum. So this will happen at 3 seconds. And that's all there is to number 9. According to the students, this is the hardest problem on the exam, so let's see if we can break this down here a little bit. We have got, we're manufacturing a box with a volume of 24 cubic feet. It's got an open top. It's twice as long as it is wide. We want to find the width of the box that can be produced using the minimum amount of material, around to the nearest tenth if necessary. Well, let's create a little box here. We've got our little box. It's supposed to be twice as long as it is wide. I doubt my diagram is going to be to scale here, but we'll have at least something to label and work with. So there we go. Twice as long as it is wide. Well, let's call this the width, and then this would be twice as long, and we have a height. We know that the volume is supposed to be 24 cubic feet. So we'll go ahead and label that on there too. We're trying to find the minimum amount of material. Well, material is surface area. So let's create a function for that. My surface area, or my material amount, is going to be, see, the bottom is 2x by x, so 2x squared. This end is x by h. There's another one on the other end, so there's two of those x by h ends. This side is 2x by h, or 2xh. There's two of those, so I got to double that. That's 4xh. I can simplify a little bit here. I've got 2x squared plus 6xh's. I really need to get rid of this h. That h is a problem because I don't want to work this in two variables. So let's go back over here we know that volume equals length times width times height. I also know that the volume is 24, and I know that the length is 2x, the width is x, and the height is h. I should be able to solve this for h. Let's simplify that up a bit. 2x squared h. If I divide both sides by 2x squared, I get h is the same as 24 divided by 2 is 12, and then we're still dividing by x squared. So h is the same as x squared. I can substitute that right in here. In fact, let's pull off just a second 6xh and replace h with 12 over x squared and see what we get. Well, 6 times 12 is 72, and x over x squared is over x. So I could write that as 72 over x, or I could write it as 72, wow, that's bad. I could write that as 72 x to the negative 1. So let's go ahead and rewrite this. My material function, or surface area, if you will, is 2x squared plus 72x to the negative 1, or 72 over x, however you want to write that. Let's take a derivative of that because we're trying to find a max or min, so we need a horizontal tangent. So my first derivative would be 4x minus 72x to the negative 2. I want to know when that equals 0. So this equals 0 when 4x is equal to 72 over x squared. Let's solve here. 4x cubed equals 72. X cubed equals 18. So it looks like when x equals the cube root of 18, we're going to get either a max or a min. We need to see which it is. So let's take a look at the second derivative here. Second derivative is 4 plus 72 x to the negative 3, which is the same as 4 plus 72 over x cubed. This is positive for x greater than 0. Therefore, we're looking at concave up, which implies a minimum, which is what we're trying to find as a minimum. So the width needs to be the cube root of 18. They want it rounded to the nearest tenth. So the cube root of 18 rounded to the nearest tenth is about 2.6. So it's about 2.6 feet. And there is number 10. Okay, our last problem wants us to use Newton's method. Newton's method is pretty much a calculator method, the way we do it. If you can't get these answers, come see me. But basically, we're taking some x value minus y1 over y2, where y1 is the function and y2 is the derivative of the function. We're storing that back into x and calculating over and over and over again until we see the numbers repeat on our calculator. The two values we should get are 0.135126985 and approximately 1.811011952. Those two values. Again, if you're one of my students and you're struggling with this, come in and see me and we'll work it out with hopefully your calculator model. That's it for this review. I'll see you guys in class.